So the first speaker is Jeff from Common Stack, and he will show the demo of using CapCat. Please welcome Jeff.
Okay, cool. So hi, I'm Jeff from the Common Stack, and today I'm going to talk about the tools we are building to scale the commons to reprioritize people and the planet. So I think it's first good to establish why the commons are important. So this is a big why of blockchain. What is the killer app of the blockchain? And I believe it's scaling the commons. And we have a bunch of wicked problems ahead of us that can only be solved together. We have climate change, resource depletion, global social unrest, and something that's very pertinent to the blockchain space is open source incentivization. So what all these problems have in common is the free rider problem. So I don't know if anybody has heard of this before. It's definitely something to look into. The tragedy of the commons. Basically, we need to come up with larger overarching social rules about how to share and allocate resources and avoid the tragedy of the commons and the free rider problem. So we have basically these global mechanisms for allocating resources, but we have some issues with our current approaches. So we have global markets, we have nation states that try to collaborate on a global level, but they have some problems. We have one-dimensional economies that optimize for profit and optimize out people and the environment. We have outdated governance mechanisms that are reactive rather than proactive in solving our growing problems. We have a lack of global coordination, which leads to a breakdown of cooperation around problems like runaway climate change. We have country A that wants to curb climate change, and country B that wants to curb climate change, but each one is pointing at the other saying, well, they're not doing enough, and so we have this breakdown and leading to the situation we're in right now. But solutions do exist to these problems, and these solutions can be found in the commons. This is communities that come together and create value-aligned economies that take care of the people in those communities and their local environments. They have local governance initiatives that are non-hierarchical, so they make decisions as a group rather than as a hierarchy, which is really important. There is still a problem with these groups is they work in small communities where trust is person to person. But when we try to scale these to global communities, we have a breakdown of this personal trust. Right now, we don't trust is person to person. We don't have a way to scale that beyond these small communities, or at least it's very difficult to. When you get to a certain size, the commons works in a village where you have, below Dunbar's number, the people can trust and understand debts and IOUs to each other. But when we try to apply that to a city on the scale of Barcelona, for example, you have a lot of free riders taking advantage of these systems. So essentially, we are trying to scale trust using the blockchain. So we have this new opportunity for global trust networks, and we can align economic incentives with community values. So when we create these networks, we can encode the values of these communities into the currencies, which is kind of the economic fabric of our coordination. And we can scale the values of each of these communities by encoding them in the currencies used by those communities. So this is what the Common Stack is aiming to do. We are scaling the commons using these blockchain components that we're creating. And these components will enable purpose-driven communities to raise and allocate funding, to make decisions, and to measure impact. So essentially, we're building a tech stack for the commons. We want to build a library of components that could include governance tools, funding tools, proposal tools, analytics tools, initialization tools, and the list could go on. This is just an idea of what components could belong to the Common Stack. There could be many more shelves, and there could be many more components on these shelves. And we are really aiming for an interoperable approach that is backed by token engineering design. So each of these components would be formulated from mathematical first principles, would be simulated and tested in CAD, and would be able to be combined into interoperable, customized DAOs, essentially, for each community and in their specific niche use case. So this is the future vision of the Common Stack, having a robust library of multiple different components that could be used for different purposes. And the importance of this is we don't think there's one answer to governance. We don't think there's one answer to funding. We think that each use case will require its own bonding curve, will require its own governance process. Maybe you need something complex like conviction voting. Maybe you need quadratic voting. We see interoperability of all of these components. There's no one answer that will work for every community. A small community may just need a 3 of 5 multi-sig, for example. A larger community may need conviction voting. An open source project may need something else entirely. But where do we start on this big roadmap of the Common Stack? So we've identified these 4 key components that will build this minimum viable commons. So first of all, we need sustainable funding. And this is something that comes up all the time. We just had a panel at DevCon earlier today about funding mechanisms. So we're working on the augmented bonding curve to provide a continuous funding mechanism for communities. We need proper proposal and escrow services. So that would be a refactored Giveth DApp. If anyone is familiar with the Giveth community, this is kind of a way that we can be sure that the money that we promise to these projects gets there. We need proper governance, so continuous decision-making through conviction voting is where the Common Stack is coming at this. And also ways to measure impact through a Commons Analytics dashboard. So this is basically closing the loop from the work that is being done in this community. How do we know that it aligns with that community's values? So we need to inform these groups who are essentially working in governance on these closing the loop to the community that is governing the funds in this community. So we need to know that what we're actually working on is delivering the impact that we're aiming for. And when you combine each of these components, this is the minimum viable commons that will essentially be kind of a library for DAOs or an SDK for DAOs of interoperable components that we can use to sorry, bit of a brain fart there. There we go. So this is where token engineering comes into this. So we're starting from a rigorous background of CAD, where we model the system, we design each of these components, and we implement them into the Common Stack library. Each of these components can be taken by a group that is interested in using these components, deploy them into a Commons initiative, and of course, once we have them live in this community, we can collect data on how this works and improve our model as we go. So this is turning it from writing a white paper and just going to code and figuring out where it fails when we're in a live environment, to an actual engineering discipline where we are starting with a model and we're seeing how these models react in the real world, and we're improving that model on each iteration. So this is turning it into an engineering discipline, essentially. So this is complex systems we're talking about. We're talking about economic systems with humans embedded in them. How do we anticipate the behavior of those humans? It's a very difficult thing to do. So these are obviously complex systems. We don't expect everybody to start from mathematical first principles, but that's where these components come from. And this is basically the basis of token engineering, is we need to define some conservation principles. And in each of our components, we're defining these core conservations that allow a robust layer for us to build higher level mathematics on top of. So once we start with the mathematics, we can jump into modeling these. So this is a token circuit diagram. So this is where token engineering has a lot of parallels to existing engineering practices. So we can model these systems in circuit diagrams and then simulate how they will work before writing the first line of code. So we can not necessarily predict how these systems are going to operate, but we can kind of determine systemic failures and systemic risks before we go to code. So if we zoom in from the minimum viable commons and just focus on our first component, so this is, we're going to be building these components one by one and testing them in a beta test environment, and then iterating on them once we find out where they work, where they don't work in a live environment. So for the rest of the talk, we'll just zoom in and talk about the augmented bonding curve, because the common stack is a very complex project, a very detailed project. And rather than getting into each of the components and how they can work together, we'll just focus on what's on everybody's mind in this space at the moment is sustainable funding. So the augmented bonding curve provides, sustainable is a big word, but continuous funding, how about that? For your project or community, there we go. So an augmented bonding curve has two phases. We've got the hatch phase, which is kind of the initialization or the crowdfunding period. And then we've got the open phase, which is when the bonding curve is live to the public. So to jump into the hatch phase, just to explain how this works, it's essentially a community crowdfund that will initialize the two funding pools of the augmented bonding curve. And these two funding pools is actually what sets the augmented bonding curve apart from most other bonding curves. So when we give the token multiple forms of value, this actually gives the system some stability that we don't see in most token bonding curves today. So to explain the hatch phase a little bit, we have a community come together, and they are going to agree to put funds into this bonding curve. So when these funds come in, they're split between the collateral pool and the funding pool by some community-determined percentage. And that goes into the bonding curve, and from the bonding curve is issued this token back to the community. So this token has two purposes. This is worth a claim on the collateral pool, which is the same as most bonding curves we see today. It's also good for governance over the funding pool, which is where this system gets a bit more stability, which we'll see in the next slide. And you can see here, this is your typical bonding curve. So just to note, this is not a time graph. So this isn't a magic money-making machine where your price goes up with time. But as more people buy or sell, you're going up or down this collateral axis. So you can have the market going up or down according to the people interacting with this market. And the interesting part of the augmented bonding curve, we can see here there's two different forces at play. So when the price of this token goes up, you have people interested in selling who are reclaiming their capital from the collateral pool. So the price decreases as more people sell. But of course, as more people sell, there are fewer people exerting governance over this funding pool. So you have buy pressure where people want to purchase this token because they want to allocate the funding from that funding pool to their projects. So you have an interplay between these two forces, which creates some volatility on the curve, which is actually turned into continuous funding through this exit tribute. So every time someone sells on the bonding curve, some funds are allocated from the collateral pool to the funding pool. So this is how we address the Ponzi scheme issue of the bonding curve, of the traditional token bonding curve. As more people sell, more money goes from the collateral pool into the funding pool, and fewer people are involved in governance. So you have this pressure, buy pressure, pushing the price of the token back up. So you're creating essentially what is a continuous funding pool for a community. So to recap the bonding curve, we're essentially creating circular regenerative economies where we have incoming capital into this economy. This is the outside economy. This is the bonding curve economy. So you have capital coming in from the outside economy into the bonding curve, which is split between these two pools. The funding pool money is then used to complete proposals, which produces value for this economy or the outside world. If you're producing open source components, for example, this is useful to everybody. And when we have capital exiting, we have this kind of circular loop where we're continuing to feed this funding pool from the collateral pool. Now, just to keep in mind, this is one implementation of a bonding curve. We could introduce all sorts of different capital input mechanisms like Harburger tax, CLR, capital constrained liberal radicalism, for anyone who was at the funding talk earlier today. So this is just one very simple implementation of a bonding curve, which is what we're really excited about with the Common Stack, is we're not just producing one bonding curve, we are producing a library of components. So if there are multiple use cases for different bonding curves, we would love to have multiple bonding curves on that funding shelf that people could take and fork and use for their use case. Another great thing about the Common Stack is when we come at this from a token engineering foundation, we can use CAD to simulate and test out these systems before we even write the first line of code. So this is a simulation we put together, which is a narrative showcase of CAD's abilities. So you can see along the left side here, we have all the parameters of the augmented bonding curve that we spoke about earlier. So how much of the raise goes to the funding pool as opposed to the collateral pool. We can actually set the hatch price and the post-hatch price of the token, and how much the exit tribute would be, as well as the vesting half-life. So these tokens vest on a curve, and you can set that. And then of course we can estimate how much would be raised by this community. And when we run this simulation, we can see the green line is the price of the token. And of course this isn't a predictive model. When you run this every time, it's a little bit different. And the blue line here, more importantly, is the amount of funds that is cumulatively going into the funding pool of this community. So this community, for example, raised almost 2 million DAI over a 52-week period. So this is essentially what we can do with CAD is test out how these systems operate before we get into actually putting money into them and finding out they don't work when there's $1 million on the line. So when we're building billion-dollar public infrastructure, it's really important that we simulate and test these systems before we go into launching them to the public. If anybody wants to play with this demo simulation, it is available online at abcdemo.commonstack.org, and you can play around with that and see how an augmented bonding curve could benefit your community. So the question now is, how can we use this in the ecosystem of today? So we have all these ecosystem funding DAOs. There's Moloch DAO, who's focusing on ETH 2.0. Metacartel is working on UX. We have art DAOs. We have open source DAOs. All sorts of different communities who are basically looking to allocate funding. And we see the augmented bonding curve as a solution for all of these communities to get them sustainable funding to continue doing the great work that they're doing. And there are a few other challenges in ecosystem funding DAOs that are more or less well known. I mean, on-chain voting is a difficult issue. We have UX issues, we have voter apathy, so this is, the accountability of funds as well. Today in ecosystem funding DAOs, when someone applies for funds, there may be, it's granted, the money is sent, and they may take off to Mexico. I mean, it's a small enough ecosystem right now that when someone gets a grant, we know them. Again, this is coming back to the commons and the trust level. When we're a small community, we trust that they're gonna do the work that they say they're gonna do, but when we scale these kinds of ecosystems, we need some kind of accountability for the funds. On-chain voting is an issue in multiple ways, and a lack of impact measurement in these groups as well. So essentially, this is the Common Stack roadmap. Each of these components is addressing one of these key scalability issues in ecosystem funding DAOs. So we're really excited to deliver this minimum viable commons for each of these groups to move forward into an age of decentralization. So over our time experimenting with this, we've realized that research and development is also a commons. And all of the token engineers that we've spoken to over the past couple of years, they're not able to research the true underlying causes of token engineering. Basically, I mean, even if they're working for big groups or big companies in this ecosystem, they're working on a very specific niche problem for that group. So R&D is a commons too. So essentially, we would like to use the Common Stack components to create the token engineering commons. And this would be an ecosystem funding DAO that will receive funding through the bonding curve, will allocate that funding towards projects that is pushing forward token engineering, and essentially bring this whole ecosystem to a new level of maturity. So we've broken this out into an iterative roadmap. So we are producing one component per iteration, and we have required fundraising for each component. And at the end, synthesizing all of these into a minimum viable commons that will be very easy for communities to implement on the ground. We have a dedicated, experienced team with multiple decades of experience. This is basically, the Common Stack is a collaboration between Giveth and Block Science. Block Science has really been pushing forward with token engineering, and the Common Stack is more or less the open source channel of the research coming out from Block Science. We have some members from Block Science in the audience today. Marcus is here. He'll be speaking about CAD-CAT afterwards. So if you have any questions about the research they're working on, feel free to hit him up. And we have some of the top token engineering advisors in the space. There's a lot of interest in basically the application of this R&D into usable crypto economic primitives for the whole crypto space to use. And we have a strong legal team as well, because ultimately there are a lot of legal entanglements that we need to be aware of and make sure we're on top of as we move forward with DAO ecosystems and how that's all going to play out in the long term. So essentially we are here today to ask you to join our growing community and contribute to the Common Stack so that we can build these components and deliver them for the space to use. And we want to ask you to help us help you realign our economies to reprioritize people and the planet. And you can find some more information on the Common Stack here. And I would open it up to some questions, if that's all right. Yeah.
So you assume that there was always a token to buy, and that token is utility token, right?
It's a what token?
Utility token.
Utility.
Yeah.
Yes.
So everything depends that the project which is going to be founded is able to construct economics around utility token. If it's not, it breaks down.
It's not a what?
It will not work. If the project is not able to make a sensible utility token, then the whole thing will not work. What you're constructing.
So, right. So this isn't a magic system for a project to provide value. We are just basically providing an economic framework for them to do so.
Right, not only for a project which is able to, which is able to construct a utility token, which makes sense.
So that we are basically providing the framework for the utility token.
Right.
So we are providing an economy for communities. So if a community is producing value, we're basically saying here's a framework by which you can launch a token, have responsible governance, close the loop with impact measurement, and sorry, am I not answering the question?
Yeah, but I mean, that was part of the question. Then the second part, what do you? I mean, do you think really that what's the share of the projects which are able to make this economics around utility tokens? Do you think that utility token is like a sensible way to do these days?
I mean, essentially, I would say what we're building here is could be functionally equivalent to a stock for a for-profit company. So you have Google or Amazon issuing an equity and saying we are going to produce value, and this equity, the price of this equity will grow. That's not guaranteeing that the value that this company is producing is going to actually grow, because perhaps they may do bad work and the price of their token will go down, the company will fail. So it's not saying that there is a value provided by these communities, but we are providing the economic framework by which they can launch the token and create these positive feedback loops of operation of the for-profit world. I don't think I'm answering your question.
Yes, I mean, another way, I would say, do you think this framework works for security tokens or for equity?
If I may interject.
Yeah, please.
I think it also depends just on the jurisdictions, because in certain circumstances, it doesn't matter how much you try to define as utility would be classified as a security.
Well,
So
that's
it's-
right, but it's about the token stuff. I mean, it's very
Yeah,
simple. I mean, you're sharing. I mean, you're selling the shares. That's that's very easy to distinguish if I'm selling a utility
Yeah.
token or I'm selling you an equity of the company.
But it still would depend on the jurisdiction. Like I know with
Well, no, I mean, if it's
T-Bow-
equity, it's always equity.
Yes, that's correct. It would always be equity if you classify it as that, and it functions as that. But like for example, what T-Bow has done with continuous organizations, which also uses a continuous fundraising system, he's done, for example, due diligence where in France the exact same thing would not be classified as security. But if you take the exact same thing to America, it would be classified as security. So
Okay,
even
so-
then, if you have the exact same thing, you use the same words, it's classified differently.
Okay, but my question is about the equity impact and non-equity utility thing.
Because it's legal issues.
Yeah. So the fact that we're using these tokens for governance as well makes it a utility in terms of, at least as far as we've seen with the legal landscape so far. And this is why we're looking at the minimum viable commons as a feature, at least feature complete to start. Because if we were to just launch the augmented bonding curve, this would be a security. Bonding curve,
Yes.
you buy in, you
No,
sell.
it's not about like classifying. It's really about like equity or not equity. Let's put it simple. Because I mean, do you think this will work for the equity thing? I mean, equity tokens.
Yeah, I think so.
Can you go back to the slide where you have it going into the two pools? You know, you have your reserve pool and your project pool, or yeah. So if you can imagine that income and capital, that collateral pool could be equity in some asset,
Mm-hmm.
right? And you could have a funding pool, or it could be DAI itself. It could just be money going into those pools.
No, but my token, the token I'm issuing, I'm selling, yes?
The ABC one, the one at
Yes.
the bottom there. So, I mean, in my situation, we're doing something very similar, right, just like this, and that token is a credit that's being used as a community currency and is being loaned into
Yeah,
existence.
but this is different because
Yeah.
okay, you can represent for a loan, but
Yeah.
equity of the company has totally different principles.
Well, but it's still a claim against that collateral.
Could be a warrant or convertible. Convertible.
equity is claimed against the whole assets of the company. not
Yeah,
about-
well, so that thing that you're using could be, it's still a claim against that collateral. It always is. No
Can you
matter
rep-
how you use it.
Can
you
you
use it a
represent?
lot of
But
times.
can you represent? Can you stick with equity on the boarding code?
Why not? I mean, whatever's, it has to be on chain. So if you had on chain assets there, or on chain equity,
Well, there is some important event, and it will raise the price of the equity or like important investment, whatever. I mean, the market will decide about it, of course, but just bounding into the curve, yes, maybe will not be related, will not, economically speaking, will not be the perfect way how we would like to model it, because you can have a jumps. Why we should like go through all the period?
yeah. I mean, maybe there's this question also of jumps.
Yes.
Like, how do you put in security around
I mean,
pump and dump schemes and things like that?
Yeah, my whole question is like, how sensible is to model the equity of the company into predefined bonding curve? Or how much sense does it make us to?
So the mechanisms that we are designing are for nonprofits in particular. If you're looking for equity for a for-profit
Okay,
company, this
yeah.
is more continuous organizations. So I mean, this is what we're talking about with mechanism design. The augmented bonding curve is designed specifically for a nonprofit use case, and it's also very feature minimal. We don't want to over-design before we start testing these in a live environment. There are many more mechanisms that could be built into a bonding curve, and we think the augmented bonding curve could be one of many bonding curves that could be used. And one for a for-profit use case would be more along the lines of continuous organizations, which is a fair amount in TIBO. So maybe that's more what you're looking for with the equity
But
question.
those are also, I think, the idea for kind of continuous organizations are also to use the bonding curve, correct?
It's a bonding curve with different mechanisms. Not
You know,
quite
capital
good.
stack, you have different classifications of investors. It's not like you're gonna pull everybody into one class. Because in a capital stack, they'll have like debt,
Right.
junior equity, right? It could be first loss type thing. You just stack the capital as you need and see fit. Companies do that all the time. That's why you have senior super at a debt level who has all rights on the company. On the equity side, they're last to get their cash out, but they may have more risk and more return. So I think you have to, one, it's a legal jurisdictional thing, which I think you're absolutely right, and two, it's a stack. And rights issues.
I just want to to your point about recycling, I would have thought, I promise I'll kill this immediately after making this comment, but I would have thought the thing that makes the distinction is whether or not it's a legitimate decision for me to go in, buy into the system, and then just pay it out to my own projects, and actually steer it in a self-interested way, or whether there's an expectation that a legitimate decision within this framework is supposed to be towards some sort of trust-like non-profit goal, in which case, as you said, into that previously, there's a question of how we would want to enforce that. So I think
well, from an investment perspective, it makes sense, but I'm not sure. It's not very clear for me as how we can issue here the equity into the loan.
But probably the thing that makes the difference is what's permissible as a legitimate decision if you hold the right to decide over that funding pool. But anyway, going to something much more technical. So you've got the exit tributes here. What's to stop me wrapping my tokens and never actually having that transfer occur? Is that something that you've taken into account when it actually matter? Or is it something you're seeking to prevent? And if so, how?
So I mean, there's a couple ways you could come at that. A, you can make them non-transferable, but of course you could wrap them, sell them on a secondary market. We've actually done some modeling with secondary markets, and the cool thing about a bonding curve is you always have an arbitrage opportunity from a secondary market back to that bonding curve price. So I mean, even if you were to introduce secondary markets, you have this kind of elasticity force around the bonding curve value. So even if you were to introduce a secondary market, I mean, yes, there would be, you could avoid the exit tribute by doing that, but there would always be an arbitrage opportunity that would cause people to, if secondary market trading were to go crazy, then people would buy and sell back to the bonding curve to bring it back, and that would be where the exit tribute would eventually come in.
Okay, so in a circumstance where all of this, say I buy in everything, and then I wrap it, sell it, and there would always be an arbitrage opportunity to enter into it as a lower price there rather than going to my hands.
Sorry, I didn't catch
Would it
that.
always be cheaper to buy it by putting in new capital as opposed to buying existing wrapped rights to that?
I might have to follow up with you afterwards.
I'm not quite sure how what I suggest so that's
If you would say sell it on the secondary market, then there would be no exit tax happening.
yeah.
But whoever receives that token would still have the arbitrage opportunity back to the bonding curve, which at that point the exit tax would be taken. So there's always an arbitrage opportunity in the bonding curve itself, as I understand it.
Okay.
Because you can avoid it going to a collateral pool and you can buy and sell directly from the court.
Yeah, right.
So once the bonding curve is live, so the hash phase is completed, and now people who want to enter in have to buy into the bonding curve. How do you visualize that justification for somebody buying into that curve? What are they thinking when they're deciding, I'm going to take my perfectly good ether, perfectly good DAI, put it into the system, or if I want to take it out, it's worth less.
Yeah, so I mean, the whole idea behind this is it's a voluntary opt-in system, so this is kind of an agreed upon tax before you come in. We definitely see this essentially is a tighter coupled loop between taxation in the community and the value that can be received from this. So it can be considered almost a speculation tax. If there's a community around global trash cleanup, and you are participating in this community, that's wonderful, but maybe you would just want to buy this token because you believe that this community is providing value, that this token will go up in price, and that you're going to sell it and make a profit. So you're essentially agreeing to pay some amount of tax into that community by profiting off that community. And this is also, we're trying to align incentives in this community as well. So we are saying this community is doing good work, you want to belong to this community, and what will allow this community to flourish and thrive is creating this circular mechanism within the community to create this continuous funding for it to continue. So this is again one mechanism. It doesn't have to be 10%. Each community could decide. You could decide to make it 0%. You could decide to make it 100%. So we're basically setting the stage for an evolution, market evolution of these types of economies. We don't know what the ideal exit tribute would be, or even if an exit tribute would work for your community. This is just one mechanism that we would like to see people experiment with and how it would play out.
Right. In our case, we're implementing this kind of stuff in Kenya, and there's a few reasons to post that hatch stage to sort of buy in, and one is for aid organizations to support the economy of that community. So as they add collateral, like seed funding from Red Cross, say, that actually produces a currency for that community, gives it collateral behind it. So, and then if the value of that drops below a shilling in Kenya, well then 1 shilling, if the community is saving or investing in these, well they're going to get more of these ABC tokens out of it. And if those are being used as a local economy, then there's a reason to fill back up that collateral pool. And then once it gets back above a shilling, well that's the time to sell it off again. So again, that market balance in and out is really important.
The part that I missed of what you just said, you're saying that there's a reason to fill back up the collateral pool?
Yeah.
What was the reason?
Because if the price is less than a shilling, then if I buy in, right, so I'm going to take some of my shillings, let's say convert them to DAI, put them into that collateral pool, well I'm going to get more of these tokens out at that point, right? So when the price falls down, then my purchasing power into this becomes higher. So I'm going to get more ABC tokens out of that bonding curve, right? So if I put 1 shilling in, then maybe I'm going to get 2 at that point out, once it's fallen down there. So I have a price incentive to sort of, I'm leveraging essentially the money I put. So once the, does that make sense?
Oh, I'll just add one thing. So, like, if you use the Red Cross, for example, we do about $1 billion a year in cash transfer. If there's enough of these around with different types of organizations that have this type of mechanism, we can toss our money in there as if we were doing normal traditional aid, be able to recycle that money at a certain point, and then allow the community to exist. And if there is a shock, say a drought or some other reasons, we can then go put our money back in there, let the economy go back up, take our money out again. It's a way to recycle capital as opposed to always going back to donors over and over and over again. I think that's a huge use case, and it's basically what we're looking at from this type of opportunity. And that's not just $1 billion from the Red Cross, that's $4 billion, $4.5 billion globally on cash transfer.
Yeah, another thing is we look, without any aid fund, we look at like savings groups. So if let's say we're a group of 25 women and we're saving every week, well we could be saving into that collateral pool and issuing a credit that we use within the community. We could loan out that credit to ourselves, right? So that there's an incentive for them to put into that collateral pool. When they need to pull back out of it, that price will drop back down, but then it becomes cheaper to add back to their savings again. So it's sort of like a savings versus a credit. So you could say that collateral pool is just a savings fund. These are 2 different kind of savings funds, and then you have a credit fund. And so right now, there's no way for groups to do that. There's no way for them to create leverage on their savings, and that would be a big thing in Kenya because there's just not enough money to save anyways. So they've got a little bit of nest egg there. How can they leverage that?
Or leverage on microfinance, or leverage on donor assistance.
Any other questions? Awesome.
Thank you, Jeff.
Thank you.